Currently, I am the Director of Construction for the Utah Department of Transportation, though I have spent the last 25 years in bridge engineering. So I'm just going to walk through some insights that I've learned along the way. But I want to go ahead and start with some history. So thinking about bridges, really what are bridges? Obviously, the first bridges were made by nature. The Industrial Revolution in the 19th century created truss systems for the industry. The first book written about bridge engineering was by Hubert Gautier in 1716, and he was a French engineer. Some of you may even recognize the bridge shown here. It is the Ed's Arch Bridge in St. Louis, stretching over the Mississippi River towards Illinois. It was designed by James Ed's and it opened in 1874. Interesting that he was a self-educated civil engineer, and it is a beautiful structure. And what about this bridge? I know many people recognize this bridge, and of course it's the Golden Gate Bridge in San Francisco. It is a beautiful suspension bridge that spans the Golden Gate Strait. It opened in May 27th, 1937. It is 746 feet high and about 8,900 feet long. It was a great feat in creating this bridge. And I love this one as well, the Brooklyn Bridge. So this is a hybrid cable-stayed suspension bridge, and it connects Manhattan to Brooklyn. It spans the East River, and it was completed in 1883. It's 280 feet high and about 6,000 feet long. All of these are amazingly successful bridges. So let's talk bridge engineering at its very basic. What does it do? It helps vehicles and pedestrians cross rivers, valleys, roads, and other obstacles. But also part of bridge engineering is taking design to construction to operation and maintain. So as part of that, being that engineer, you prepare design plans, calculations, specifications, and cost estimates to get these bridges built. So look at this construction photo. I don't know if any of you recognize it, but is the new bridge from Oakland to San Francisco. Very successful, correct? These two are another amazing bridges. That top photo is the new River Gorge Bridge in West Virginia. Beautiful steel arch, and it's over probably 3,000 feet long. That bottom photo is the Arthur Ravenel Bridge in South Carolina that connects Charleston to Mount Pleasant. Its cable-stayed bridge has its main span of over 1,500 feet. It's the third largest in the Western Hemisphere. Again, very beautiful, successful bridges. But what about these? What do you think? These are box culverts, tunnels, small pedestrian bridges. Would you still say that they're successful? I would. So I've shown you some amazing, spectacular bridges. But the interesting thing about that, they only make up 1% of the inventory on bridges. These simple bridges, as you see here, or simple roadway bridges that you drive across and you probably don't even recognize that you're on a bridge, make up the remaining 99%. So, successful? Again, think about these. These are some photos of some accelerated bridge construction. Photos where we're now moving bridges into place, building them offline. They're not all cookie cutter situations anymore, and the industry continues to evolve and finds new and better ways to do things. And I would call this successful because we are continuing to evolve our industry. So what about these photos? I know you're looking at them and you're saying, oh my gosh, that cannot be successful. They're all failed. What's going on here? But I want you to consider this. And I'll give you a little bit of history. So this is the Tacoma Narrows Bridge, and it failed November 7th in 1940. And that was due to wind. We have the I-10 after Hurricane Katrina on August 29th, 2005. And then there's the Silver Bridge collapse. And this was between West Virginia and Galapagos, Ohio. Trying to say that right. So on that one, 46 people died when an I-bar chain failed on that suspension bridge. It was only 39 years old. So when I say, is it successful? We learn from our failures. Everybody makes mistakes, things fail. And it's what you do with those failures that make it successful. You improve the design for the future. So let's talk big picture perspective now. These are just some of my ideas that I like to think about when I'm topics surrounding what bridge engineering is about. You have aptitude and technical excellence, a quality perspective. You need to perform quality work, and that's to protect the safety of the public. You have project delivery. You need to know how to move from design to construction into operate and maintain. I like to look at multidisciplinary teams because you will never work alone. Don't ever think you will. You need people to make a project successful. Then you have constructability and construction. You need to make sure what you design can actually be built. And then there's bridge management, which is something when I was a consultant, never really thought of because I moved on from one project to the next, to the next, to the next. But the owner is required to inspect and maintain that bridge for its life. And so that is a whole other side of what bridge engineering is about. And then innovation, constantly looking to improve. And when you hear that statement, well, that's the way we've always done it, it's probably time to do things different. So a little more detail on aptitude. I like to think of it as like you really pay attention to detail and you possess a solutions-oriented mindset. You're problem solving, critical thinking. But another thing is really practice professionalism in the way you interact in your project teams. And I like to work with enthusiasm. If I didn't love it, I wouldn't be doing it. And technical excellence, and that's kind of obvious, mathematical, science mindset. Think through a problem, address a problem. And then constantly gain more and more experience, try new things, and continue to evolve in your career. Don't be scared of something, ask questions, and build on the knowledge and expertise of your mentors and the people around you. Quality perspective. And I think I mentioned this earlier, that quality is extremely important because that's how we build quality projects so we can protect the public. And in most departments, we set up, and it's called quality control, quality assurance. So I have two photos here, and this is after the Minnesota bridge collapse on August 1st, 2007, in which 13 people were killed, 145 injured, where this was 1,000 foot of deck truss that collapsed. So the National Transportation Safety Board performed an investigation and found an inadequate guidance for QCQA. And so the industry was tasked with how are we going to improve our processes to protect the public. So from a state perspective, an owner's perspective, what do? We develop and implement a program and we call it QA/QC. We also like to select qualified design teams and we match experiences with the project complexity. And it's really important that you ensure that the procedures are followed. So why do we as engineers need, this quality perspective? Because we produce a bunch of stuff. Memos, plans, calcs, reports, or emails, electronic documentation. It's endless the amount of things we have. And we need to make sure that what we're producing isn't just from one person, that somebody else has checked it and then another entity has independently verified that that procedure was followed. So let's talk why. It's important to document those procedures and you create accountability to limit that liability on an owner. You also need records to maintain that bridge for the future. We're continuously improving and learning from successes, but we're also learning from those mistakes. And so that's why we try to capture all this so we can move the industry forward into the future. So here's the photo of the new Minnesota I-35 bridge. It is just over 1,200 feet long and carries about 10 lanes of traffic. It opened on September 18th, 2008, and construction started on October 30th, 2007. So if you look at that timeline, what was created in 1 year? Another success. This bridge is pretty amazing. It even lights up in different colors. And I believe the governor gets to choose what colors those are. All right, let's move into project delivery. And I kind of mentioned earlier, we need to get from design to construction. And you work with a lot of different team members. So this is UDOT's Project Delivery Network. And all the different colors represent different disciplines involved in the project. And so this process will take from design to advertising. So that's how all the team members work together and the flow chart and process. And I know it looks busy, but it makes sense. And this is what helps guide the department in getting projects completed. So some other important parts of project delivery, and if you get into this industry, which I highly recommend, you will hear constantly whenever it comes to projects, scope, schedule, budget. What is it? Scope, schedule, budget. But there's also, you have to understand the risks associated with the project. And every project is very different. And we always want to build quality and innovation into the projects. Communicate with your team and project stakeholders because they can have a lot of input in making your project better. There's a lot of different procurement methods that we use as a department, which is a typical design bid build. We also use design build, and we also use what's called contractor management general contractor, which is a CMGC aspect. So a typical design bid build is there's very distinct parts. You design it, you bid it, and then you build it. There's design build where we hire based on qualifications, a contractor that brings along their own designer for the project. And then the CMGC, the owner hires a contractor and a designer, and they work together to deliver that project. So there's a lot of different things that go into project delivery. So for all the math and science out there, analysis and calculations. So I always find it funny when I tell someone I'm a bridge engineer and they say that, well, that must mean you do a lot of math. And I'm like, yeah, there's a lot of math involved, but it's all fun. So a lot of analysis and calculations are governed by AASHTO codes, and state owners also have their own design requirements. And there's a ton of different software packages out there to help develop their designs. So looking at plan development, this is only one part of the puzzle. So a designer has to communicate that design that they just analyzed and worked through. Somehow you need to tell the contractor what they have to go build. And how do you go about doing that? You develop a plan set. And so it represents all of that work you just did, provides dimensions, directions, quantities to the contractor. So think of that as your primary communication tool to the contractors. So every state would have some standards and specifications that accompany those plans that are developed. So take this, for instance, this is a specification of a pre-stressed concrete. So this provides all the requirements to the contractor on associated with that item, the material they have to use, submittals they have to do, and the plan set also tells them what that beam has to be. And all of these pieces will work together. We have measurement and payment that also accompanies what we call this bid package that I'm showing you. So there is the bid item number, name, unit, and how that contractor is to bid that item. So you can also add descriptions to add clarity, but this is how the contractor will bid, will be based on bid items. So we also have cost estimates, and that's required up front. So they could be an engineer's cost estimate. So we have to understand what it's going to take to build that bridge. So the engineer, designer in the most cases, go through, they design it, they put the plans together, they figure out all the quantities, and then we put cost to them. And that is called the engineer's estimate. And all of these things go together for a bid package. And that is how we advertise a project to get it built. So multidisciplinary teams, again, you've seen the project network, but I want to highlight like how all of these work together. You have structures, the environmental aspects, utilities, right of way, roadway design, geotechnical design. All of them work together to deliver this project. So UDOT is also very progressive in the way that we approach communicating with the public. We get a lot of political capital because we're always keeping the public informed. We create ads, we're on the radio, we create project highlights. And because we do that, we get a lot of that political capital. And I want to show you this video because it's one of the videos that we prepared for a project. And let's see, here we go.
In a world that's in a hurry, where the people cried out for a better way, one interchange dared to break the mold. Coming soon to the I-15 interchange at American Fork Main Street, Utah's first diverging diamond interchange. It's a whole new way to get on and off the highway. The diverging diamond interchange, because in traffic, no one can hear you scream. Test drive it at Utah.
So as you can see, UDOT puts a lot of effort into advertising their projects. One of our main goals is to minimize the impacts to the public. And the more communication that you can get out to the public, the better off your construction projects will be. So now let's look at constructability and construction. You can design anything, but if you can't build it, forget it. So a lot of things we build into the construction side of things are pre-bid meetings. They're typically held for really complicated projects. Pre-construction meetings are held with the project team prior to starting any work. And again, nothing is ever perfect, especially in construction. Things change. So you have to be flexible while you work. Within the requirements of that contract, you need to know the contract. And most importantly, to document those lessons learned on every project so that you can improve your processes and procedures as you move forward. And when things do go bad, remember to communicate and partner, work together towards a solution. It doesn't do anybody any good to argue and fight. Let's work together and where the owner and the contractor come up with that solution together to move that project forward. So bridge management, and again, I think I mentioned this earlier, this was the aspect that I just really didn't understand when I was in consulting. You know, the owner really needs to live with this bridge for 75 years, and that's a long time. Bridges are inspected every 2 years and their condition documented in a management system. And every year that bridge condition information is submitted to Federal Highway. We perform a lot of load ratings based on that condition of those bridges, because as bridges deteriorate, you have to continually monitor that and update those load ratings based on the condition of the bridges. So when you take all of this information, you also end up using it in your planning practices to develop future work on the bridge, whether that is a bridge preservation project, a bridge rehabilitation project. Um, I mean, I was the chief structural engineer for 10 years here, and I saw a lot of things. And I put the emergency repairs on here because most people don't think about that. And as you can see within these photos, an oversized load just decided to knock out some girders on one of our bridges. And I guess as an owner, you can think about it as, you know, similar to your car getting hit. You got to go do something and you got to go fix it. So let's talk innovation, because this is really the fun stuff that is moving the industry right now. So we have accelerated bridge construction is a big initiative of the department here. We're always looking at advanced materials, drones, and then we're moving into this digital delivery world. So let's talk ABC. We have prefabricated bridge element systems, bridge slides, and self-propelled modular transporters. So the department has probably completed over 200 bridges using some form of ABC. And again, I think I mentioned this to minimize the impacts to the public and deliver a project faster. So here's a few photos. You know, you could kind of even think of it as Lego bridges, maybe. You develop the sections and then you kind of put them together in the field. A bridge slide. I'm going to show you a video of a slide here. We've actually found Bridgeline is one of the most efficient ways to replace a bridge. Really minimizes the impacts to the public. On this structure here, I think this is just one night, and I believe it only took them about 6 hours total to get the bridge in place. And you'll see here they're putting down some prefabricated elements now on the sleeper slab. And here they're going to start to slide it. And please note the magnitude of contractor resources out there to make this happen for us overnight. This bridge was open the next day to full traffic. I think they actually start using the bridge to drive their equipment over, which probably was not OSHA approved, but we don't talk about that. Okay, here's a self-propelled modular transporter that we completed. And this video is very amazing. It's one of the first 2-span bridges that were ever moved with SPMTs. It's highly skewed, extremely complicated geometry. And again, the freeway was closed down at night. It was built on the side of the road. They swung it in overnight, and the next day they did all the tie-ins, and the bridge was open the next day, or not the next day, but within that week as they got the tie-ins completed, and there was no impacts to our mainline interstate. So a lot of advanced materials. So the industry continues to advance in a lot of material aspects. And really a lot of it is about preserving and extending the life of bridges. So ultra high performance concrete has mechanical properties, compressive strengths in excess of 21 KSI. Highly, if you're interested in that, visit the Federal Highway website. They have so much information on it. Fiber reinforced concrete, stainless steel reinforcing, polyester concrete overlays, all of those aim to improve durability. That we have the geosynthetic reinforced soil integrated bridge systems. We've completed one bridge using that system, and it consists of altering layers of compacted fill, and then closely spacing this geosynthetic reinforcement that really serves as the bridge abutment, so you can build a bridge really quickly. So unmanned aerial systems, the department has a really robust program here. I talk about an industry that can go anywhere. We use it in so many different areas: construction, measuring quantities, public relations, public involvement. But to look really at what it can do for bridges, it can look at the imagery that you can see. And then you can go back and see it later. And the major thing about this is really improving the safety. Instead of the bridge inspectors being in traffic or hanging over the side of a bridge in a bucket, trying to evaluate this condition, you can go fly the bridge and evaluate the condition of the bridge when you're back at your computer. And if you have to see things multiple times, you just pull it back up. So this technology can change bridge inspection for the future. So digital delivery, this is all very evolving. Think of it as we're moving from a PDF plan set into digital delivery where it's models. But you can kind of compare it similar to when the industry went from hand-drawn Mylars to actual computer-generated plan set, that became the PDF. We're now evolving into the next or the future, which is all digital and model-based. And the thing with digital delivery, within those models, you can attach all the data you want. So this photo right here kind of shows the outline of the model, but think you had a bridge deck. You can say what the concrete strength is, what the reinforcing in it is, what the spacing is. All of that can be attached and used for future planning. So it is going to definitely drive the future of project delivery and within construction. So I want to show you this bridge here. We completed a bridge. It's named SR36. So it was our first project in which the bridges within the project, the digital model was the legal document. There were no plan sets associated with this project that went into construction. So as you can see, this is just the reinforcing. So you can see conflicts if you laid it out wrong. The contractor can take this to help produce their bar. The suppliers can use it to check quantities. So we're really moving into this digital world. And then here I want to highlight, you can see the model before it was ever even constructed. And the picture on the right, that's the picture from construction. So hopefully you have a very different perspective on bridge engineers, I guess is a good way to say it. But in summary, thinking about the characteristics of bridge engineers. Again, it's work well with others, develop that technical excellence, be flexible, learn from your mistakes, and don't be afraid to ask questions. We don't know everything. But I started to think too of those non-engineering aspects, communication, whether it's writing or verbal, being able to present your ideas and collaborate as a group. We're all in this together. And, I can honestly say that being a bridge engineer is extremely rewarding. I've loved every minute of it. I wouldn't change my path in any way. So I think if you're interested, go do it because it's a ton of fun. So thanks for your time today. That's all I have for presentation, but I'm more than welcome to take any questions.
Thank you, Carmen. I do see one question in the, we have a Q&A here. What is the most difficult part of the job of a bridge engineer?
The most difficult part of a job. Looking at, I would probably say, I'm going to give two answers here. So I would probably say collaboration on to a certain degree, because I think engineers tend to be very introvert, don't really like to get out and communicate much with each other. And so you're kind of dragging information around. So I think that's one side of it. But I also think that on the technical side of it, there's a lot of codes and things that govern it. And so I think, once you get in and you understand the theory behind it, the rest will come really easy. But getting in all the code and understanding how it works, and then understanding how it goes into the design from construction, because I think we tend to get in our silos. Like, I'm design, you're construction, and understanding that it's a whole process that needs to work together. And I think when you first start to get into, working in this industry, not everybody quite understands that we're all here to work together.
Great, really good answer. Thank you. We have another question from Dr. Shi. Thank you for the outstanding presentation. Can you talk about how you got interested in becoming a bridge engineer and what motivated you in college to stay in this field?
So I don't remember this, but this is what my mom tells me, that I went to one of, I think what would be known today as a STEM webinar or a STEM meeting. I must have been in grade school, and she tells me I came home and I said that I was going to be an engineer. And interesting enough, by the time I was in high school, for some reason, my internal drive, I just knew that's what I want to do. But I really kind of looked at it more like, I want to build things. I want to go build stuff. So I honestly thought that I would always be, on the construction side of things and not the design side. And then when I went to college, and it's really the only thing that interests me was, because structural engineering here was within civil engineering. And, that's transportation, that's traffic studies, which I'd never want to do, by the way. And, other aspects. And I just, instead of going on the construction side, I really liked the design side. So that's kind of how I ended up being on the bridge design side of engineering. But I don't know, I guess I always just wanted to do it.
All right, so a little further questioning on that. Considering the multidisciplinary nature of bridge engineering work, what suggestions do you have for civil engineering students in college? What mentality and skills should they prepare for?
So I know one thing that I know when I got out of college that I was disappointed in is, college is really good at preparing you for theory and all of this detailed things that you may not necessarily use again, but you understand the basics behind it. But, I never took a plan reading class. I didn't know how to read a set of plans. I didn't know how my calcs would go into a set of plans. They didn't teach you how that would get relayed or described to a contractor. I think that is something that I think within the universities is to provide that practical knowledge. Like I didn't get that in college. I got that when I started on a design build project and they they gave me this thing called Ashtail Code, and they said, design this bridge deck. I'm like, okay. So it was feast or fire, and so I think, I think if universities could provide some of that more practical knowledge, I think it would help draw more people into bridge engineering.
Very good. Yeah, thank you for that. A couple more questions. Dr. Carloni, thank you for this great presentation. In your presentation, when you covered advanced materials, you didn't mention GFRP bars, and I was wondering if you have any comment or opinion on that.
I just don't have necessarily the experience with the GFRP bars. The department has only completed, we did some trial research, I want to say maybe 10 years ago. I think so. And we only used it on 2 bridges, and it's still in the research phase for us. So I didn't include it just because I didn't have the experience, and we don't necessarily have that outcome on our research yet.
Okay, thank you. Another question, what is a typical career path as being a, I think she meant to say, in being a bridge structural engineer? How to grow into an outstanding engineer from an EIT?
I think right when you get into, at first, learn as much as you can from everybody around you. I think that is, get a mentor, ask questions, be flexible. You may be asked to do like some ridiculous thing, but there's probably a reason behind it that they're not telling you. And so I think really learning all of the technical aspects around structural engineering is really important. You'll notice, like, as you advance your career, though, you probably get to a place where you become this technical expert, or you take the management road. And so, I went so far with my technical skills, and then I was being asked to go manage projects and manage programs. And so I chose this path of more the management leadership aspects of bridge engineering. Though, don't get me wrong, I love bridge engineering. I mean, I'd love to go design a bridge today. I haven't probably in a few years. But once you gain that technical knowledge, I mean, I can still look at a plan set and be like, that's wrong. They can't build that. Go change this. Like, to have that solid background is really important on no matter which direction you choose in your career.
Okay, thanks. Another question came in. On advanced materials for bridges, you listed polyester overlays instead of other types of overlays. Is there a special reason for that?
We use a lot of thin bonded polymer overlays. The reason I listed the polyester concrete overlay is because for UDOT, we just recently implemented that type of overlay here. We know that California's used it a lot, and in a lot of other states have used it. Well, we just hadn't used it here, and so it was something new for us. And so that's why I listed it on advanced materials for this presentation.
Okay, can you also comment on some research needs you see in bridge engineering from a state DOT perspective?
Research needs. I still think that there is a lot of work in concrete mix designs and the durability aspects of those. There seems to be today a lot of souped up mixes, as you would call it, plasticizers, too much paste. There's just a bunch of things being put into these. And at least from the UDOT standpoint, we're finding that that mix is just not as durable as, say, 40, 50 years ago. So I think there's a lot of research that could be done on mix designs that would help within bridge design.
So this isn't really a question, just a comment. Dr. Panelide says you were an excellent structural engineering student designing pre-stressed girders for a hospital. So no surprise you transferred that to bridge girders.
Well, thank you, Dr. Panelide. I got my master's under him, so. Thank you.
I don't see any other questions that have come in. We'll give a few more seconds in case anyone else has any last comments. We certainly appreciate your time today, Carmen, and your expertise. And I'm sure that this video is going to be really popular. So this is recorded, and we will post this on our website as soon as we get the recording and have done a little bit of editing. So that will be available on our TriDurLE website, which is hosted in YouTube as well. So I don't see any other questions. So I think.
Well, thank you all for your time. I really appreciate it. And if you have any questions, please reach out to me. I'm happy to answer anything.
All right. Thank you so much. Have a great day.
Yes, you too. Have a great evening. Thank you.
Bye.
Bye.